Okay, we're gonna do the chain rule. This is the big one. Okay, this is the big rule. And at first it'll seem confusing, then it will seem easy, and then you realize it's not necessarily easy or confusing, but it can be a little bit of both. It can be challenging, it can be easy. It's like all of calculus, all of math, that it has elements that are very simple and elements that are very, very complicated. But this is the big dog, okay? This is the it. Like, quite frankly, almost every question after today, like we're in 2.5, we're in 2.6, 2.7, 2.8, 2.9, 3.1, 3.2, almost everything's gonna have a chain rule aspect to it. So this is really an important one, okay? It's a really important one, isn't it? If it's gonna be something that we're gonna be doing over and over again. Now, this is it, this is the rule right there in that box. If h is a composite function, remember we've done composite functions before where we drop g into the f box and then come out. Right? We practiced this in Algebra 1 and Algebra 2, right? The derivative is the derivative of f of g of x times the derivative of g of x. Now I'm going to do the proof of it in kind of a backward sort of fashion. I'm gonna end up at that answer almost by accident in a sense. Like I'm gonna actually just think it through. Now, I'm gonna have to change the way we think about the question though. I'm gonna call g u and g of x u and f of u y because I wanna, it makes sure you understand why I'm doing that. I wanna put u in, I'm gonna call that u. And then I wanna make that the function y. Now, if I call this u, the derivative is du dx. That's how we write the derivative. Notice I have to go back and use this notation. The derivative of y is the derivative of y is dy divided by whatever the variable is. Now, look what happens when I put y prime times u prime. Du dx times dy. Actually, I wrote that backwards, didn't I? Let me just slow down here. It's all exciting, right? So notice that is, so that's the du dx, and that is the dy du. Notice the du's are going to cancel, and notice you get your normal derivative that we want. So when I substitute that in here, and why did I do that? Y prime is just this, isn't it? And the g prime is just this one, isn't it? So it turns out that if you do this, you get the derivative of y with respect to x, which is our normal everyday derivative that we want. That would be h. Okay, there's kind of the proof of it. Now, well, don't panic if that's all strange. You guys, when you actually see it work, it flows, okay? It makes sense. It makes way more sense than you might think, okay? Now, here's the problem. And let me just do some examples, and you'll go, oh, this is easy. Okay, I'm gonna explain why it's not, but don't get lulled into a false sense. This is actually very easy. That's the g function inside the, so all you do is you cover it up and say, oh, I want the derivative of f. What would the derivative be if I covered this up? So watch how this works. This is not that hard. The derivative, if I covered it up, would be 5x to the fourth. So you take the derivative as if what's in the parenthesis is the function, but then you have to multiply by the derivative of what's inside. So you got 3x squared plus 1 times 6x. I'm not going to simplify these because I want to leave them in there in the formula state. So you do the derivative of f of x. F of x is x to the fifth. but there's a g in it. So it's going to be 5x to the fourth, but there's a g in it, and then you have to remember to multiply by the derivative of whatever's inside. And that's what we call the chain rule. Try it again. And hopefully by the time we get done with these 4 examples, you go, oh, this isn't that bad. And then we'll kind of go, and then I'll kind of burst your bubble on it, okay? Here, again, you treat this like x to the 1/2. Well, what would the derivative be if it was x to the 1/2? It would be bring the 1/2 down, subtract the power. But then this isn't x. So it's 7x plus 1, so you have to do a derivative of what's inside. Okay. Here, again, you cover it up, and then you bring the -1 down, and you reduce the power by 1. But what's inside isn't x, is it? It's x squared plus 3x plus 2. So you have to do that chain rule thing where you have to take the derivative of what's inside. X plus 3. And then last but not least here, cover it up. Way you take the derivatives, bring the power down, reduce the power by 1. But you have to realize this is not x. It's x to the 5th plus 7x. Then you have to multiply by the derivative of what's inside. This is the chain rule part. So now, notice what I did. I covered integers, fractions, negative, and then negative fractions. And the rule holds. Basically, you're taking, remember back to the formula, you're taking the derivative of f with whatever's inside, but then you have to multiply by the derivative of what's inside. So again, looking them again, you cover it up, whatever's in the parenthesis you cover up, and you take the derivative as if that was x. So that's 5x to the 4th, but then you have to multiply by the derivative of what's inside. Again, you cover this up, and you say to yourself, what would the derivative be? 1/2 x to the -1/2, but it's not x, so you have to multiply by the derivative of what's inside. And what I'll always remind you is did you do the chain rule? Because sometimes people forget to multiply by the derivative of what's inside. You cover it up, you bring the power down, subtract 1, and then take derivative of what's inside. You cover it up, you bring the power down, you reduce the power by 1, but then you have to remember to take derivative of what's inside. Now let's look at some trig questions. What if you have cosine 6x? Let me put it in parentheses. Same idea. You cover it up and you say to yourself, what's the derivative of cosine? The derivative of cosine is negative sine. But it's not x, it's 6x. So then you have to multiply by 6. You have to do what's called a chain rule on that. Secant. Remember, you cover up this part and you say, okay, the derivative of secant is secant tangent. Now, here's the thing. What's behind my hand is x squared. But then you have to remember to multiply by the derivative of what's inside. So again, notice that the chain rule thing does not work. It works for any function, not just power rules, right? Now, what you have to realize is, you might be thinking, Mr. Peters, what if it's the other way around? Yeah, we have to cover those too. What if this is just x, but that's the 5th? Oh, that's no big deal. This is like the ones we were just doing before we started trig. You cover it up. Oh, that's x to the 5th. So its derivative is 5x to the 4th. But what's behind my hand is tangent, so you have to remember to do a chain rule on what was in the parenthesis. Now this is a little asterisk. You might be wondering, what if it's both? Oh crap, this is called nested chain rule, and is annoying. You might, what if I put the two questions together, kind of? What if I put the 5th power with a 6, right? What if I got 2? Here's the deal. I've got 2 chain rules. So you got two parentheses, don't you? So you got to cover up the big one and say, what would it be if it was x to the fifth? If it was x to the fifth, it would be 5x to the fourth. But then I have to take the derivative of what's in my hand. Now don't get scared, but what's behind my hand is another chain rule. What's the derivative? And then you have to cover that one up. What's the derivative of sine? The derivative of sine is cosine. But what was in there? A 6x, so then you have to multiply by 6. Now, the rule isn't super challenging on its own. Here is the thing I need to warn you about, okay? That's it, that's the chain rule, okay? And this is called nested chain rule when this happens. When this is very rare, okay? Just kind of pointing that out. What makes the chain rule challenging for students is when we start mixing it with quotient rules and product rules. So when we start doing the homework on this, it is going to get challenging. But in the final analysis, this is what you have to memorize. F of g of x is f prime of g of x times g prime of x. This is literally, let me get rid of all the stuff in the box that's not necessary. This is it. Okay?